Welcome. In this video, I will talk about binary numbers and its related concepts. So let's look at the topics that I am going to discuss in this video. I will first talk about what is binary number system. Then I will talk about how to convert decimal number to binary number. I will also talk about how to convert binary number to decimal number, and then I will discuss these four operations of binary addition, binary subtraction, binary multiplication and binary division. This is going to be a slightly long video, so I would suggest you that you can check it as per your requirement. For that, I will put the time stamp in the description as well as the comment section. So let's start. I hope you are all clear about the decimal number system. In this number system, we use 10 digits from 0 to 9. Hence, the base of this system is 10. Thus, in this system, the rightmost position represents 10 to the power 0, called units or ones place. Second from the right represents 10 to the power 1, and so on. What I mean by this, suppose I have written a number like 2375. So it is a number in the decimal number system, and here the rightmost digit, that is 5. So what is the value of this 5? This value of this 5 is 5 into 10 to the power 0. Similarly, if I ask you what is the value of this 7, so the value of this 7 is 7 into 10 to the power 1. And what is the value of this 3? So the value of this 3 is 3 into 10 to the power 2. And finally, the value of this 2 is 2 into 10 to the power 3. So you can see that we are starting from the rightmost digit, and we are multiplying it from we are multiplying it by 10 to the power 0, and then the second digit from the right by 10 to the power 1, third digit from the right by 10 to the power 2, and fourth digit from the right is 10 to the power 3. So that is what we are going to get. We are going to get here 2000 and plus 300 and plus 70 and plus 5, which is 2375 in the decimal number system. So this is something that you already know, right? It was just a idea that I wanted to recall. Now let us look at the binary number system. First of all, let us get an idea about it. So you might be aware that computer plays an important role in our daily life. It receives, stores and processes the information or data using the two digits 0 and 1. So computer work with the digits 0 and 1, and these are very important digits for the computers. And these two digits are called binary digits or bits. So any number however large can be written using the two digits 0 and 1, and these are called binary number. So since we are using just two digits, that is 0 and 1, so this number system is said to be binary number system, and the base of this number system is 2 because we are using two digits, that is 0 and 1. Okay, now the first thing that I want to discuss, that how to convert the decimal number to the binary numbers, right? So this is the first important question which are usually asked. So the process is very simple. I will explain it through different examples. So let us start with the first problem. Suppose I want to convert, so 8 is a number in decimal number system, and I want to write 8 in the form of binary number system. So the process is that I divide 8 by 2. So when I divide 8 by 2, I get 4 as the quotient and 0 as the remainder, right? Now I repeat the process. I divide 4 by 2 again, so I get 2 as the quotient and 0 as the remainder. Moving ahead, I again divide 2 by 2. So in this case, I get 1 as the quotient and 0 as the remainder. So once I have reached to the last step where I have either got 1 or 0 in the end, now I will write the binary digit in this direction, starting from this 1 here and moving in this direction. So what I will write, I will represent this number as 1 0 0 0. So 8 in the decimal number system, which I can represent like this, is equal to this digit in the binary number system. I hope it is clear to you that what I have done. I have just represented the number 8 in binary number system. Let us take another example. So here I have the number 12. So what I will do, I will write 12 and I will repeat the same process. I will divide 12 by 2. So if I divide 12 by 2, the quotient will be 6 and the remainder will be 0. Then again I will divide 6 by 2, the quotient will be 3 and the remainder will be 0. Again I will divide 3 by 2, so the quotient will be 1 and remainder will also be 1 in this case, because if you divide 3, the quotient will be 1 and remainder will be 1. Now we have got 1 here, so I can't divide it further by 2, so I will end the process and then I will write the number in this direction starting from 1 here. So that binary digit representation will be 1 1 0 0. So the number 12 in the decimal system can be represented as 1100 into the binary digit system, right? I hope you are following it. Now let us take the third example. Here I have a bigger number, so we have the number 63. So I need to be slightly more careful. So what I do, I start with again the same thing. I will divide 63 by 2. So I will get the quotient as 31 and remainder as 1. Again by 2, the quotient will be 15 and remainder will be 1. Again by 2, the quotient will be 7 and the remainder will be 1. Again I will divide it by 2, so the quotient will be 3 and the remainder will be 1. Again I will divide it by 2, so quotient will be 1 and remainder will be 1, right? So here we have reached to that number 1, so I can't divide it further by 2. So I can represent this 63, which is in decimal form, as in binary digit as 1 1. How many ones are there starting from there? 1 2 3 4 5 6. So I will write 1 1 1 1 1 1, and this is how I will represent this in binary number system. So I hope you are getting it. Now I have the next number, that is 569. So I have to represent 569, which is in decimal form in binary form. So let's start the same thing. Start by dividing it by 2. So if you divide it by 2, it is 569. So if you divide it by 2, 280 will give you 560. So it will be 284, the quotient, and the remainder will be 1. Now you divide 284 by 2. So quotient will be 142 and remainder will be 0. Now again you can divide it by 2. So the quotient will be 71 and here also the remainder will be 0. Divide it by 2. The quotient will be 35 and the remainder will be 1. You divide it by 2, the quotient will be 17 and the remainder will be 1. You divide it by 2, the quotient will be 8, remainder will be 1. You divide it again by 2, the quotient will be 4, the remainder will be 0. 4 can be divided by 2, quotient will be 2, remainder will be 0. And 2 can also be divided by 2, so quotient will be 1 and the remainder will be 0. So here we can see that if I have to represent the number 569, which is given in the decimal form, so binary digit representation will be, so 1 and then 3 zeros, so I am writing 1 and then 3 zeros and then 3 1, so 1 1 1 and then 2 0 and then finally 1. So this is the representation in the binary system. So I hope you are getting the process. The process is very simple. You start dividing the number by 2 and divide it till the very end, till the time you are not able to divide it further by 2, and then you write the remainders or final quotient and then remainder in this direction. So this is how you represent it into the binary form. I hope it is clear. In case if you have any doubt, put the doubts in the comment section. So moving forward, I am going to talk about how to convert the binary number into the decimal form. So the first part is over. The second part is converting the binary number system to decimal number system. So here I think you are already clear that, as I have told you, that here the base is 2 because we are working with only 2 bits, that is 0 and 1. So here if I recall the decimal number system representation, I can take a hint from there, and the hint from there is that here I will multiply the extreme right digit by 2 to the power 0, this digit by 2 to the power 1, this digit by 2 to the power 2, this digit by 2 to the power 3, and this digit by 2 to the power 4. So for our convenience, what I can do, we can count. So we have 1, 2, 3, 4, 5. So total 5 digits are there. So the digit in the extreme left, that is 1, will be multiplied by 2 to the power 1 less than 5, that is 4. And then again 1 multiplied by 2 to the power 3, and then 0 multiplied by 2 to the power 2, and plus 0 multiplied by 2 to the power 1, and plus 1 multiplied by 2 to the power 0. So that is equal to what? That is equal to 16 plus 8, and this 2 will give me 0, so no need to write, and this will give me 2 to the power 0 is 1, so this will give me 1. So how much we get? We get 25. So basically what is happening in the next problem, I am not going to write all the details, because as you can see very clearly that here we are. So here let us look at the next problem to understand it better. But before I take next problem, I just want to highlight this, that basically the bits here in different positions are can be seen like this. Like the first position will be 2 to the power 0, the second position should be multiplied by 2 to the power 1, the third position should be multiplied by 2 to the power 2, and so on. So this should actually contribute to 1, then this 2, then this to 4, and then the next digit will contribute you to 8, and then 16, and then 32. So if you can remember this also, it will be easier for you to kind of directly answer the question. So I am going to take few more problems to highlight this. So suppose I take the second problem. This was the first one. Let me take the second one. So here we have 1 1 1 1 4 times 1, and then 0 1 and 0. So I hope you will be you will allow me to write it directly. So how many digits are there? 1 2 3 4 5 6 7. So I should multiply this will contribute 2 to the power 6. So 1 into 2 to the power 6. It is not meaningful to write 1 into 2 to the power 6, because if I multiply something by 1, it will remain the same. So I am directly writing it 2 to the power 6 for this one. Then for this one I can write 2 to the power 5, and then for this one I have to write 2 to the power 4, and for the next one I have to write 2 to the power 3, and plus. Now this is 0, so 0 into 2 to the power 2, if you want to write, you can write 0 into 2 to the power 2, but it is meaningless because 0 will not contribute anything. So it is better to just remove it, right? So I just removed it, and then it is second position, so I will multiply it by 2 to the power 1, and finally also we have 0, so no need to write. So if I add all of this, this is 64 plus 32 plus 16 and plus 8 and plus 2. So how much I will get? I think it will be 40. So this will give you 40, and this will be like 64. So 104 and 16, 120, and plus 2, so that will be 122. So this will be 122, right? Now let us look at the third one. So third one, I think I should be able to write directly. So let us write the answer directly. Count the number 1 2 3 4 5 6 7 8 9. So there are 9 digits here. So starting from here, I will write, for this I will get 1 into 2 to the power 8. For the next one I will get 1 into 2 to the power 7, and plus. Then there are 2 zeros, so no need to write anything. Now we have this one, so this is coming in 1 2 3 4 fifth position, so I will write 1 into 2 to the power 4. The next one is coming in fourth position, so 1 into 2 to the power 3, and then plus 1 into 2 to the power 2, and then we have 0, so no need to write, and then we have finally 1, so 1 into 2 to the power 0. So I hope you got the pattern. You have to multiply the digit 0 or 1 by 2 to the power 1 less than its location. Let me rephrase it. What I am saying, that if a particular digit is coming in 7th position from the right, I should multiply it by 2 to the power 6. If it is coming in nth position, then I will multiply it by 2 to the power n minus 1. So that is the idea. So if I simplify it, I will get what? 2 to the power 8 will be like 256, 2 to the power 7 128, 2 to the power 4 is 16, 2 to the power 3 is 8, 2 to the power 2 is 4, and 2 to the power 0 is 1. So if I add all of this, 256, 128, 16, 8, 4, 1. So how much is that? That will be like, you can add it, you will be like getting 413. You can verify, this will be your answer. So I hope the process is clear to you. You can write any random number, and then you can find out that what is the value of it. I'm just going to write a few numbers, and I would ask you to write its decimal representation in the comment section. Like suppose I take the number like 1 1 1 1 1 0 1 1. Let me write the answer for this also. So what should be this? 1 2 3 4 5 6 7 8. There are 8 digits, so I will start with 2 to the power 7, then 2 to the power 6, then 2 to the power 5, and then 2 to the power 4, and then 2 to the power 3, right? And then 0, so no need to write it, and then this is coming in the second position, so it will be 2 to the power 1 and plus 2 to the power 0. So whatever you will be getting will be the answer. So the homework that I want you to answer is that write the decimal representation of the number 1 0 0 0 0 1 1 1, first one, and the second one is write the decimal representation of 0 0 1 0 0 1 1 1 1, right? So that you can answer. Now moving ahead, let us look at the next thing, that is binary addition. So binary addition is done in the same way as we do the addition in the decimal system. And in binary system, actually there are only 2 digits, that is 0 and 1. So there are 4 possibilities, and those possibilities are that what will be, we get if I add 0 and 0. So 0 plus 0 will be 0, 0 plus 1 will be 1, 1 plus 0 will also be 1, and 1 plus 1 will be 0, but this 1 will carry over to the next left column. So what I mean by that will be clear from some of the examples that I am going to take. So here I have taken 2 examples. I can add more examples here also. So suppose I have to add 1 1 1 and 1 0 and 1. So as I have told you that 1 plus 1 will be what? 1 plus 1 will be 0, as the rule suggests that 1 plus 1 will be 0. But then there will be a extra 1. So that extra 1 will be carried over to the next next left column. So that 1 will be carried over to here, right? So now we have 1 and 1. So this 1 and 1 will give me 0. And again this 1 will be carried over to the next left column. So we have 1 1, that is 0, and then 1 will be carried over to the next left column, and 0 plus 1 will give me 1, and we already have a carried over term, so that is 1 1 0 0. I hope you got this addition. Okay, now let us look at one more. So suppose we have 1 0 1 and then 0 0 1, and we have 1 1 0 and 1 1 0. So what is the process? 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 1 is also 1, 1 plus 0 is this is like 1. Why I am writing 0? So this is also 1, and I think this is very clear. And 0 plus 1 is 1, and 1 plus 1 is 0. but 1 will be carried over, so this will be carry over term, and here we have 1, right? So this is how we add it. Let us take few more examples. Suppose I am changing the color also for better clarity. Where to change the color? Color options. Okay, I will change it later. So suppose we have 1 1 1 1 1 0 1, and we have 1 1 0 1 1 0 1. So how can we add it? You can see 1 plus 1 will be 0, and this 1 will be carried over to the next column. So now here we have 1 plus 0, that is 1, and 1 plus 0, that is 1. So no need to write anything, just 1. Now 1 plus 1 is 0, and this 1 will be carried over to the next term. Okay, now here 1 plus 1 is 0, right? So but once it will be 0, there will be a 1 which will be carried over to the next column. Now we have 0 plus 1, so that will be equal to 1, right? Now we have 1 plus 1, so that will give me 0, but 1 will be carried over to the next term. Now we have 1 plus 1, that will give me 0, but then 1 will be carried over to the next column. So 1 plus 1 is 0, and 0 plus 1 is 1 here, right? Again here 1 plus 1 is how much? 1 plus 1 is 0, but 1 will be carried over to the next column, and 0 plus 1 is again 1, and here we have 1. So this is how we can find the sum. Now some of the times it may happen that you may feel like whether you have done it right or whether you have done it wrong. So we can also verify this, and when I say we can also verify this, we can verify this by using the decimal addition system. So suppose I have this number here, so this number will be equal to what? If I change this number into the decimal, it will be how many digits are there? 1 2 3 4 5 6 7. So 2 to the power 6, that is 2 to the power 6, that is 64. This number will be 2 to the power 5, that will be 32. This number will be 2 to the power 4, that is 16. And this number will be 2 to the power 8, 2 to the power 3, that is 8. This will be 2 to the power 2, that is 4, and finally 2 to the power 0, that will be equal to 1. So the value of this number will be 64 plus 32, that is 96. 96 plus 4, 100, and 100, and this is 25. So this is basically 125. And how much is that number? So this number will be equal to we have 1 2 3 4 5 6 7. So 2 to the power 6, 64. I am writing it here in the bottom. 64 plus 2 to the power 5, so that is 32. And here we have 1 2 3 4. So this is fourth position, so 2 to the power 3, that is 8. This is third position, so 2 to the power 2, that is 4. And this is the first position, that is 2 to the power 0, that is equal to 1. So how much is that? 96 plus 4, that is 100, and 109. So this is 109. So if I add this, how much I get? 9 and 5, that is 14, 1 carry, and 2 plus 1 is 3, and 1 plus 1 is 2. So I should be able to get 234 here. Let us see whether I am getting 234 here or not. So we have 1 2 3 4 5 6 7 8. So there are, this 1 is coming in 8th place from the right, so it will be equivalent to 1 into 2 to the power 7. So 2 to the power 7, and then 2 to the power 6, and then 2 to the power 5, and then it will be 2 to the power 4, but it will be 2 to the power 3, right? And then it will be 2 to the power 1. So how much we are getting? We are getting 120. Wait a minute. So what is the value that I am getting here? I just went out to receive some parcel. So it was like 2 to the power 7. So that is 128, and plus 64 plus 32 plus 8 and plus 2. So how much is that? 128, and it is 96, and then 10 here. So how much we are getting? 8 and 6 14, 1 carry, 2 2 2 1 3, 9 3 12, 1 13, 1 carry, and 1 1 2, that is 234. So you can see here that the sum is 234. So this is how you can verify also. Now moving ahead, we are already 24 minutes into the video. So moving ahead, we are going to talk about the binary subtraction. And here also the process remains the same as the decimal system. Only thing that you need to be careful about, that 0 minus 0 will be 0, 1 minus 0 will be 1, and 1 minus 1 will be 0. But 0 minus 1 will be 1 with borrow from the next column. So when I was adding, I was taking the carried over term, but here I am going to borrow from the next column. So the process will be clear if I take few examples here. So let us take few examples. Like suppose we have to subtract 101 from 110. So here we have, let me change the color. I think red is more clear. So from 110 I have to subtract 101. So if I have to subtract this, so here in the very first place you note that and subtraction is slightly confusing, so listen very carefully. So we have to subtract 0 minus 1. So 0 minus 1 will be 1 as the rule suggests, right? But because we have to write 1 here, we have to take 1, borrow 1 from here. So if I borrow 1 from here, this will become what? This will become 10, right? This will become 10, and 10 is what? 10 is basically 2. So that is why if you write 10 in binary number system, let me repeat the whole process so that you do not get confused. What I am suggesting, that some of you may argue that why we are writing 0 minus 1 is equal to 1. So the explanation is that if I take 1 borrow from this column, we have a 0 here, and if I take 1 borrow, I will get 10. So what is 10? 10 is 1 into 2 to the power 1 plus 0 into 2 to the power 0. So that is equal to 2, right? So now this number becomes 2, and 2 minus 1 will be equal to 1. So if you have taken 1 borrowed 1 from here, it has become 0. So now 0 minus 0 is equal to 0, and here you have 1, so 1 minus 1 is equal to 0. So the answer that you have got is 0, 0, 1. If you want to verify this, so through using decimal system, so what is 110? 110 is basically, here this is 2 to the power 2, so 4, and 4 plus 2 6, so this is 6. And if you look at this, this is 2 to the power 2, 4, and plus how much is this? 4 plus 1 into 2 to the 5, so it is 5. So 6 minus 5, that is equal to 1. I repeat it, if I write 110, so 110 in decimal system will be what? It will be 2 to the power 2 plus 2 to the power 1 and plus 0 into 2 to the power 0. So that is basically 4 plus 2 is equal to 6. And if you have 101, so 101 in the decimal system will be what? It will be 2 to the power 2 plus 0 into 2 to the power 1 and plus 1 into 2 to the power 0. So that is equal to 4 plus 0 and plus 1, that is equal to 5. So 6 minus 5 is equal to 1, and here also you are getting 1. So this is 0, 0, and 1 into 2 to the power 0, that is equal to 1. So I hope you are getting it. Now let me take this second problem here and explain to you that how does it work. So here we have the number that is 1 1 0 1 0 1, and I have to subtract 1 1. Actually it is having 1 digit less, so I have to write accordingly, because I told you that I follow the same process as we follow in the decimal. So there are how many digits here? 1 2 3 4 5 6. So 1 2 3 4 5 6. Now it is 1 1 0 1 1. So I will write it like this: 1 1 0 1 and 0. Now I have to subtract. So 1 minus 0 is 1. 0 minus 1, so that will be equal to 1, but 1 will be borrowed from here, right? So it will become 0. So 0 minus 0 is 0 now. Now here you have 0, so 0 minus 1 will be 1, but because I have to take borrow 1 from here, so it will become 0. Now we have 1 here, so this will become 1 0, that is 2, and 2 minus 1 is equal to 1. So what we have got? We have got 1 1 0 1 1. I hope the process is becoming clear to you. In case if you have doubt, I would suggest you that let me know that what is your doubt. I am going to take few more problems so that you are absolutely clear about the process. So suppose I have something like I take this number that is 1 0 1 1 1, and from this suppose I want to subtract, that is 1 0 0 0 and 0. So you can very easily subtract. 1 minus 0 is 1, 1 minus 0 is 1, 1 minus 0 is 1, 0 minus 0 is 0, and 1 minus 1 is equal to 0. So there is no challenge here. It was very easy. Suppose I take one more. So suppose I have 1 1 0 0 0 1, and from this I have to suppose subtract 1 1 0 0 1. So if I have to subtract, 1 minus 1 is 0, 0 minus 0 is 0, 0 minus 0 is 0, and then it 0 minus 1. So again we have to borrow 1 from there. So this 1 0 1 0 becomes 2, so 2 minus 1 is equal to 1, and now this becomes 0. So here if I take 1, 1 minus 1 will be equal to so it is like I repeat this, there may be some confusion. So what I am suggesting here, that it is 1 minus 1 0, 0 minus 0 0, 0 minus 0 0. Now here we have 0, so 0 minus 1 will be equal to 1, right? And it is 0 here, so if I take this 1, it will become what? It will become 1 0, so it will become 2, and 2 minus 1 will be equal to 1. Are you getting this? Because this is a point of confusion some student may have. I repeat the process so that you don't have any confusion. The confusion point is that some of you may argue that 1 minus 1 is 0, no problem. 0 minus 0, no problem. 0 minus 0, no problem. 0 minus 1 is 1 as the rule suggests. So why this is 1? Because if you take 1 carry from here, what you get in this position? You get 1 0. So 1 0 is basically equal to what? In decimal form it is equal to 2. So 2 minus 1 will be equal to 1. Now if you take 1 borrow from here, this will become 0. So if this will become 0, and then this 1 will be taken over, so it will become 1 0. So 1 0 is what? 1 0, as you have already seen, that it is equal to 2. So now 2 minus 1 will be equal to 1. So don't make the mistake of writing that 1 minus 1 is equal to 0, which some of the student may make, right? So this is all about binary subtraction. Now moving ahead, I am going to talk about binary multiplication and binary division. So in binary multiplication also the rules remains same. The rules are that 0 into 0 will be equal to 0, and 0 into 1 will be equal to 0. So only thing is that 1 into 1 will be equal to 1. So I am going to take examples to illustrate. One more thing that I want to highlight here, that when I am writing these questions here, it is written that add the following binary numbers and check the result by converting them to the decimal system. So I am not checking the result by converting them to the decimal system. You can just check it on your own, that whether it is okay or not. I believe that once you convert it to the decimal system and then verify, you will get the same answer, right? So now let us talk about the binary multiplication through different examples. So we have two numbers like 1 0 0 1 and 1 0 1. So the multiplication works the same way. We take 1, we multiply to all the digits, so I will get 1 0 0 1. Then we take 0, we multiply the all 4, so I get 0 0 0 0. And then I take 1 and again I multiply, so I take 1 0 0 1. And then we add, so we get 1 here, 0 plus 0 is 0 here, 1 here, we have 1 here, we have 0 here, and we have 1 here. So here there is no confusion, because it is very obvious that the process is similar to the process of multiplication that we have done in decimal. Now let us look at this one. So we have 1 1. Let me write it slightly below, so that if there will be some carryover term in the addition, it should have the space. So what I am saying is that we have here 1 1 0 1 0, and I have to multiply it by 1 1 1. So I am writing quickly 1 1 0 1 0. Then repeat the same thing, 1 1 0 1 and 0, and then repeat the same thing, 1 1 0 1 0, and then add it. So 0 1 1 and 1 1, that is equal to 0, and then 1 will be carried over to the next term, right? Now look at this, 1 plus 1 will be 0, and then this 1 will be carried to the next column, and 0 plus 1 will be equal to 1 here. Now 1 plus 1 0, 1 will be carried over to the next term, and 0 plus 1 is equal to 1, and here 1 plus 1 is equal to 0, and then this 1 will be carried over to the next term, so this is 1. So what we get? We get 1 0 1 1 0 1 1 and 0. So I hope you can verify it through decimal conversion also, which I leave for you as an exercise problem. Okay, so let me can I take few more problem, or I guess it is clear to you. So just one more problem I think I should take. Let me change the color also so that you are absolutely clear. So suppose I take a problem that I have to multiply 1 1 0 1 1 0, and I am multiplying it by 1 0 0 0 1. Slightly lengthier problem so that you get the confidence that anything can be multiplied. So just multiplying it by 1, nothing will change, so I will write 1 2 1 1 0 1 1 0, and then there are 3 zeros, so everything will be 0, so I write 0 0 0 0 0 0, then again by 0, so I write 0 0 0 0 0 0, and again 0, so I write 0 0 0 0 0 0, and then by 1 again, so I will write 0 1 1 0 0 1 1 0, and then 1 and then 1. I hope it is slightly clumsy, but there is no confusion. Now I have to add all this, so 0 will be brought down, then 1 plus 0 is 1, then 1 plus 0 plus 0, that is equal to 1. 0 4 times, that will give me 0. 1, it will give me 1. 1 plus 1, it will give me 0, but 1 will be carried over. Now 1 plus 1 will give me 0, but 1 will be carried over. Now 1 plus 0 will be 1. 1 plus 0 1 1 1. So this is what we get, 3 1 2 0, and then 1 0 double 1 and 0. So this is how the multiplication works. Now moving ahead, let us talk about binary division, and as you can see that as we have seen in the decimal also, the division by the number 0 is meaningless, right? So same is true with binaries also. So you can't divide something by 0, so only possible options left are that what if I divide 0 by 1. So 0 divided by 1 is 0, and 1 divided by 1 is 1. So how does it work? It works exactly the same way the division works in decimal number system, but it will be more clear if I solve some problem. So we have the first problem, that is 1 0 1 1 1 1, and I'm going to divide it by 1 1 and 1. So you can clearly see that 1 1 1 is greater than 1 0 1. I hope this much sense you already have developed, that if you take one time, so you cannot write it directly under this, because 1 1 1 is greater than 1 0 1. So if I take 1 times, I have to write it 1 1 and 1 here. Now I have to subtract, so 1 minus 1 is 0, 1 minus 1 is 0, and here it is 1 0. So if I take 1 here, it will become 0, it will become 1 0, that is 2, so 2 minus 1 is equal to 1. So I get 1 0 0. I hope subtraction process is clear to you, because subtraction is the thing that I see students making a lot of mistake, right? But after doing so many problems, I believe that you don't have any challenge. Now what is the thing? You have to bring this 1 down, so I get 1 here. So we have 1 0 0 1, so again I can take it 1 time, so I will get 1 1 and 1. Subtract it, 1 minus 1 is equal to 0. Now 0 minus 1 is equal to 1, but what I get here, I have to borrow 1 from here. Now here see, it is a point where a student will be making lot of mistake. 1 minus 1 is 0, 0 minus 1. So now there is no 1 here, so I have to take borrow from this one. So if I take borrow from this one, look at this very carefully, and let me change the color also so that confusion can be avoided. If I borrow this one from here, what I will get? I will get 1 0. So basically 1 0 is what? 1 0 I have told you is equal to 2, right? Now if you take 1 borrow from here, it will become 1 0, that it will become 2. Now 2 minus 1 will be equal to 1, right? Now it was 2 and you have already taken 1 borrowed, so 2 minus 1 here, so it is now 1 left. So 1 minus 1 will be equal to 0 here, and you already have taken 1 borrow, so this is already 0, right? So finally you have to bring this 1 below here, right? Now if you bring this 1 below here, you notice that 1 0 1 is less than 1 1 1, so you don't have to do anything, you just have to place a 0 over here. So I hope that you have got the sense that here the quotient is 1 1 0, and what is the remainder? The remainder here is 1 0 1. The zeros coming in the left is meaningless, so the remainder here is 1 0 and 1. I hope the process is clear, especially the subtraction part that I have done here. Now let us take one more problem to illustrate it in a better way. So we have 1 1 1 and then 0 1 0 1, and I have to divide it by 1 0 0 1. So clearly I can see that 1 1 1 0 is greater than 1 0 0 1, so I can take it 1 times, and I will write 1 0 0 1, right? And I have to subtract. So if I subtract, it will be like borrowed from this, so it will become 1 0, that is 2, so 2 minus 1 is equal to 1 here, and it is 0, so 0 minus 0 is 0, 1 minus 0 is 1, and 1 minus 1 is 0, so no need to write in the left. Means here writing 0 will be meaningless, so I just leave that. Now I bring this 1 here, right? Now clearly 1 0 1 1 is more than 1 0 0 1, so I will take one more time, so I will get 1 0 0 1. Now again subtract, 1 minus 1 is 0, 1 minus 0 is 1, 0 minus 0 is 0, and 1 minus 1 is 0. So this is basically 2 zeros. It is insignificant, there was no need to write this. So in case if you don't want to write, you just can ignore them. So you get just 1 0 here, right? Now you bring this 0. So if you bring this 0, you note that 1 0 0 is less than 1 0 0 1, so you have to put a 0 over here. Now you bring this 1 here, so now you can see that you have to take it 1 times, so you'll get 1 0 0 1 1. So if you subtract, you will get 0 0 0 0. So what is the quotient here? The quotient here is 1 1 0 1, and what is the remainder here? So remainder here is 0 0 0 0, which is actually equal to 0. So this is how we can do the division. So in this video I talked about how to convert binary numbers into decimal numbers, how to convert decimal numbers into binary numbers, how to add binary digits, how to subtract binary digits, how to multiply binary digits, and how to divide binary digits. So that is all in this video. In case you have understood the things, you should like the video and you should share the video with all your friends also. This video is meant for all kind of a student. I prepared this video keeping in mind the requirement of class 11 applied maths course. So there is a maths course, there is a applied maths course which is offered to the student in CBSE. So in case if you are you have opted for that course, this video is meaningful for you. So that's all. Thank you and great watching.